Hello friends, welcome. Today I am recording a video with the title What is Bandwidth? Now this video is part of the series which I have recently started to explain complex terminologies related with wireless technologies to the layman. And this I am attempting to do without getting into complex mathematics. Now friends, why this is important? This is important because these terminologies we are using routinely in our day-to-day lives while describing various kind of services being offered by the operators. So therefore it impacts our lives. If we understand these concepts a little bit more deeper, we will be able to appreciate that how a certain quantum of bandwidth is going to change our ability to experience a certain service and what are the implications of these terminologies over other terminologies related to wireless technology. So without wasting any further time, let's begin. Friends, we all know what is bandwidth. Bandwidth is nothing but the capability to transmit more data. More the bandwidth, more the data that you can transmit. But why? That's the whole purpose of this video. Let's understand why when we have more bandwidth, we are able to transmit more data. Now friends, if you look at this particular slide, you will see that this slide has got two figures, one top, another is bottom. So let's focus on the top. The top figure is a series of ones and zeros, which is a digitized information which is being transmitted through an electronic channel. Because ultimately, this is the signal which is being consumed by the electronics or processed by the electronics to deliver services. Everything is a digitized form. Now, when you are transmitting these ones and zeros through a wireless channel, exactly what happens? Let's understand that. Now, friends, this square wave can be constructed faithfully by adding multiple sine waves of different frequencies and amplitude. So what I have shown here, if you look at this particular block which is encircled by red, I have blown this and I am showing you multiple sine waves of different frequencies all adding up to trying to reconstruct this square wave. Now this particular figure is a little undulating in nature because the total number of sine waves that I have added here in this figure to reconstruct this Y wave is limited in nature. It's finite in nature. It's not infinite. So, in order to faithfully reconstruct this Y wave, you need infinite number of sine waves of different amplitude and frequencies. Now, you really don't have the capability to transmit infinite number of sine waves over the wireless channel because you will need infinite number of bandwidth because the total number of sine waves of different amplitude and frequencies determines the bandwidth of the wireless spectrum because as the frequency is going to increase, because if you should see that the first sine wave has got a certain frequency f0 and then as the amplitude decreases the frequency increases. So if you have to carry all the frequencies, you have to pack it within this block of spectrum of a certain bandwidth. So if you have to carry infinite number of frequencies, then you require infinite number of bandwidth, right? But you really don't do that. Why? That is a very important concept. Let's understand this. Now for that, you have to go to this particular chart. So this is nothing but a small representation of a complex wireless network, or basically the transmitter and the receiver. I have only shown one transistor here. Transistor is nothing but a switch and an amplifier. What it does, it basically inputs the complex wireless undulating waveform with noise as I represented here. If you see this, I have basically inputted this here in this input and then faithfully reconstructs this particular wave which we want to process in the receiver. Now how it does it? It does it by switching this amplifier on and off. So as soon as you input a positive value here, this particular switch opens and therefore this output can be read either as 1 or 0. So when you are not inputting anything here, then it is 0. When you are inputting something here, some voltage here, it becomes 1. Now the input value, what you are basically putting inside into this transistor may not be exactly 1 and 0. It can be a distorted waveform as long as this switch is able to understand by looking at a certain reference value that whether the value of the signal is above that particular reference or below that particular reference. So you need not be accurate when you are making an input inside this switch. So that is what is important, and that's what decides that how many sine waves that you need to carry. Now let's say if you have a digital wave of a lower frequency of a larger time period, then what happens is that you need not carry a large amount of sine waves. Why? Because then what happens is that this particular transistor will get some time to react. Look at this wave. If this wave was of a larger time period, then as you input a certain value, the reaction time of this switch is going to be high enough to decide by looking at this particular wave, which is the input which is coming, whether it is 1 or 0. But if the time period is too short, then this particular switch will not be able to decide, because the time within which the input is going to remain 1 is going to be so short that it has to decide within that particular short time period whether it is 1 or 0. Therefore, the reference level which you are going to feed into this switch has to be accurate enough. Otherwise, this switch will get confused. And that is where you need to carry a large number of sine waves here, so as to make this reference level flat. That's where you need large amount of bandwidth. So as the data rate increases, as the frequency increases of this particular square wave, in order to faithfully reconstruct this, you need to carry a large amount of sine waves, and that is where you need large amount of bandwidth. So this is simple as that. Now you understand that why large bandwidth carries data at a higher bit rate or a higher speed, and why small bandwidths carry data at a smaller speed. That's the concept here. Okay, so this is as simple as that. Otherwise, if you go with the terminology of Fourier series or going to complex mathematics, it will become so confusing that nobody will understand anything. So I thought to extract the complexity out and explain this to as simple as possible, so that even a layman can understand that why higher bandwidth carries data rates of higher speed and lower bandwidth carries data rates of lower speed, because the electronic circuit should have sufficient time that it should get in order to respond to a certain value of input. And if the response time is too low, then the input has to be of a higher quality, so that the decision making can be done quickly and efficiently with higher fidelity, so that the output can be reconstructed. 1 and 0 can be reconstructed. And that's where you need the surface of this wave flatter, and therefore you need to carry large number of sine waves. Therefore, the bandwidth will be higher. Now friends, I think I need to stop here, otherwise the concept videos are going to become too long and therefore people will lose interest. So thank you for your patient listening, and next time I will come back with a new concept and try to explain things as simple as possible. Thank you very much, and let me know your feedback in the description section. Thanks a lot.